Hello, and welcome to Unit 5 of this year's chemistry course, where we will be talking about the mole. Um, a little bit of where we're headed. There are 7 different sections as we go through this unit. The first one we will be discussing today, and basically we'll be talking about what is a mole. But you can see him will be talking about moles and mass, percent composition, how to convert between mass and moles, how to convert between moles and particles, how to convert between volume and moles, and then we'll talk about molecular and empirical formulas. So a lot of math going on in this chapter. Please make sure you have your calculator with you at all times because it will be definitely needed as we go through this chapter. So today we are going to talk about what is a mole. And it's not one of these little furry creatures that pokes out of the ground in your yard. I mean, it is, but not what we are going to be talking about throughout this section. Um, as we go through this unit, starting out, these are the things that you'll need to know. So by the end of this video today, this is what you will need to know. You'll need to make sure you can recognize that a mole of a substance is equivalent to 6.02 times 10 to the 23rd units of that substance. And you also will need to make sure you understand that the mole is a manageable quantity that is used by scientists to count a large number of very teeny tiny small particles. So let's get into it here. What is a mole? Basically, a mole is a name for a specific quantity of things, just like a dozen or a pair. Both of those have very specific numbers that are associated with them. Um, and a mole is the same thing. It is just a unit that has a specific number associated with it. That number is 602 hexillion, which is a super, super big number. You might not have even heard that. It's way past billion and trillion. When we get to 602 hexillion, that number looks like this. This is 602 hexillion, which, if you counted all those zeros, it is 602 with 21 zeros after it. So that is a super large number. It would take you way longer than the rest of your life to count up that high. Um, One thing that a mole is not, it is not abbreviation for molecule. It's spelled the same as the first 4 letters in the word molecule, but it is not an abbreviation for molecule. That is where a lot of people get confused. So just make sure that you remember that a mole is like a dozen or a pair. It names a specific quantity. It could be molecules, but it doesn't have to be, and is certainly not an abbreviation for that. The other thing you might hear the word mole called is Avogadro's number, named after the man who not really discovered it, but started to use it to classify large quantities of molecules and atoms. His last name is Avogadro. So sometimes this number is called Avogadro's number. So if you hear that, don't be confused. All right, starting off with a softball question here is kind of work through this concept. How many donuts are in a dozen donuts? Hopefully, you got the right answer and said 12. Okay, let's make it a little harder. How many donuts are in 1 mole of donuts? Remember, it's the same type of situation, just with a different number. But in a mole of donuts, there are 602 hexillion, or 6.02 times 10 to the 23rd donuts. So if you think of 602 with 21 zeros, that many donuts is a mole of donuts. All right, let's try a couple other questions. How many jelly beans are in a dozen jelly beans? I said I'm going to give you a dozen jelly beans. I would be giving you 12. Dozen always means 12, regardless of what it is. If I said I'm going to give you a mole of jelly beans, How many jelly beans would I have to give you that many jelly beans? A mole. Hopefully you're kind of getting the pattern here. But a mole of jelly beans is still 6.02 times 10 to the 23rd, or 602 with 21 zeros. That's a lot of jelly beans. That is a big, huge pile of jelly beans. All right, couple last questions. How many anythings, like fill in the blank, are in a dozen anythings? If you have a dozen, doesn't matter what it is, fill in the blank. Cars, cats, pizzas, milkshakes. If you have a dozen, you have 12. Doesn't matter what it is, right? If we ask that same question, we say how many anythings are in a mole of anythings. Same thing, right? A mole is always 6.02 times 10 to the 23rd. So there are 602 with 21 zeros after it. There are that many whatevers in a mole. Doesn't matter what it is. All right, so let's bring this kind of back to chemistry for a minute. Where on earth did that sort of strange number come from? And actually, what it is it is the number of atoms equal to the number of atoms in exactly 12.0 grams of carbon 12. So, carbon 12 is a very pure substance. It is something that is readily available, it is something that is easily measured. Um, so, when scientists took 12 grams of carbon 12, so those match 12 grams, carbon 12. Remember, carbon 12 means it has 12 protons plus neutrons in its nucleus. Um, there are 6.02 times 10 to the 23rd atoms. So they decided to just say, okay, that is the number that we're going to use to be a mole, right? Kind of like dozen. Like, where did they come up with a dozen? They just kind of random picked a number and said, this is what we're going to call it, right? It probably wasn't random, so never mind. But same way they came up with how many atoms are in a mole. All right, so I said earlier, if I gave you a mole of jelly beans, that'd be a really big pile of jelly beans, right? How big of a pile do you think it would be? Like, think about that for a second. If you had 602, 21 zeros after it, if I gave you that many jelly beans, how big of a pile of jelly beans would you have? Don't eat them all at one time, you get a stomach ache. But the pile would be, you ready for it? As big as the earth. The whole earth, not just covering it, but from center out, you would have that many jelly beans. So we're talking, this is a huge, huge, huge number. Almost too huge to even really get a grasp of in our heads. But that is a lot of jelly beans. Let's go back to our donuts. Right. Stack up a mole of donuts, one on top of each other, just like in that picture there. Stack, 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 stack. How high do you think my stack would be? You got your guess in your head? How high you think that stack would be? All right, here it is for real. Long enough to reach from the Earth to the Sun and back 200 billion times. So if you could stack up a mole of donuts, it would go back and forth from the Earth to the Sun 200 billion times. That's a lot of donuts. That is a huge, huge amount of donuts. All right. Again, let's bring it back to chemistry for a little bit. So let's say I have a mole of water. Right? You know what water is? It's hydrogen and oxygen, H2O. So you got one atom of oxygen attached to two atoms of hydrogen. How big do you think a mole of water is? I'll give you a hint. A molecule of water is a lot smaller than a donut. Um, you got your guess? So a mole of water is 18 milliliters, 0.07 cups, which is around somewhere between 2 and 3 tablespoons. So it's like a swallow of water is not a whole lot. How about a mole of sugar? So sugar molecule is 6 carbons, 12 hydrogens, 6 oxygens, all stuck together. That's one molecule. If I had a mole, if I had 6.02 times 10 to the 23rd of those molecules counted out, how big do you think it would be? It actually would be less than a pound. So not a whole lot at all. Why do you think that is? Jot that in your notes. Give your explanation for why the moles of water molecules and sugar molecules are so much smaller than that of jelly beans and donuts. I mean, jelly beans was the whole earth, and water was a drink of water. And that's a huge difference in size. Why do you think that is? This picture, just to kind of give you an idea of the size of some of these, um, I have a couple things sitting there in this picture. That aluminum foil in a ball there, that's a mole of aluminum. It's about the size of a baseball. You see there the water in the graduated cylinder in the back. That's about a mole of water, 18 milliliters. Um, there's a mole of copper in that beaker right in the center. A mole of sugar cubes in the back there, and then a mole of salt in that beaker on the right hand side. So just to kind of give you a picture reference, that's the sizes of those different things of a mole. 6.02 times 10 to the 23rd molecules, we could count them out. That's how big they would be. How big of a pile they would make. That's the best way to say that. All right, so think about this question for a second. Why do you think scientists use the mole? So why is this important? What does it matter? Why can't we just count them individually? You got your idea? And it is because we can't count them individually, right? I mean, that would just be, A, we can't see an atom, we can't see a molecule, so they're impossible to count. So this is just a way to get something that is more of a visible size that is easier to work with. Like it says in your notes, you can kind of think of the mole as a bridge connecting that microscopic world, the atoms and molecules that we can't see but that make up everything, to the world that we live in. Because you can see a pound of sugar, you can see 18 milliliters of water, you can see that baseball size of aluminum, right? So those are tangible things that we can see and understand. An atom, a molecule, we can't see those things. So it's a whole lot more difficult. Like if I said, give me 600 molecules of water, I mean, you can't do that. But if I say, give me a tenth of a mole of water, well, that you can do very easily. So it just connects all those things together. And we'll see more as we go on in this section how that works a little bit better. All right, so that's where we're stopping on our notes from today. You do have an assignment. It is up in Canvas. It is titled Relative Mass and the Mole. You'll see it's a worksheet that is in Canvas. Do the first 2 pages. There's a little stop sign. You'll see it'll tell you where to stop. But don't go any further than that. You can go ahead and stop right there. And this will be due by class time tomorrow. So you've got your notes and you've got that assignment due when you come to our Zoom class tomorrow. So 9:30 in the morning, we're going to have our Zoom class. I'll go over the assignment. We'll talk about some things, and I'll make sure you have the link to that.